Assalamualaikum warahmatullahi wabarakatuh. I'm Madatu Mashta binti Muhammad Tamizi. I'm from Group 9. Today, I would like to present our assignment titled Solve Engineering Problems Using Matlab Software on Topics on Application of Differentiation and Integration. So, this is my group mates, No Farah Fakiha binti Muhammad Rizal Khan, AE 220051, Nur Arina Naziha binti Muhammad Nawawi, CE 220067. For the first equation, number 1 is evaluate the following functions using integration by part in Matlab. So one Roman is integrate x to the power of 3 ln x dx by using the integration by parts method in Matlab software. So after comparing the computed solution using direct integration, which is F2, with the answer computed using Matlab's integration by parts approach, which is F1, we discovered that it is challenging to verify the accuracy of the answer generated using the integration by parts methodology. As a result, we decided to tackle the given issue in Matlab using the direct integrate approach. First, we use the SYMS method to dynamically construct a variable. Thus, the symbol variable x was created using the common SYMS. This can assign it to a Matlab variable of the same name automatically. Next, we identify a function by utilizing the label f and the inline command with calling x acting as the function's independent variable. This is f, and we call this independent variable because it the side of left, the left side is variable independent variable, and the right side is not in like inline x to the power of 3 times log x and x. So we continue to the Matlab int command is then used to integrate the function fx. We use the petty command with the supplied solution to make the Matlab calculated result simplicity. This is int f bracket x close bracket. And the answer is x to the power of 4 times log x minus 1 over 4 close bracket, and this is the answer x to the power of 4 times log x minus 1 over 4 close bracket and over 4. And the last one is pretty. The answer it will show like this. Okay. The full view of the coding. This is the coding in Matlab, the full coding. So SYMS x f equals to inline, and then f equals to inline function fx x to the power of 3 times log x int f open bracket x close bracket. Answer, and the last one pretty in answer. By using manual calculation, this is the formula for integrate by part. Integrate u dv equals to uv minus integrate v du. With using the acronym LIATE, let ln x as u and x to the power of 3 dx as dv. So u equals to ln x, du over dx equals to 1 over s. This we differentiate this, and we differentiate ln x, and we got 1 over x. And then we just let du to the left side and equals to 1 over x dx. So dv equals to x to the power of 3 dx. Integrate dv equals to integrate x to the power of 3 dx. And then we continue to integrate open bracket x to the power of 3 ln x close bracket dx equals to open bracket ln x close bracket, and then open bracket again x to the power of 4 over 4 close bracket minus integrate open bracket x to the power of 4 minus integrate open bracket x to the power of 4 over 4 close bracket, and then open bracket 1 over 4 close bracket dx. and we got the answer is x to the power of 4 times ln x minus 1 over 4 plus c. The solution is accurate since the results of the manual calculation and the results of the Matlab calculation are identical. 2 Romans, the question is integrate e 2x cos x dx by using integration by part method in Matlab software. So this is our Matlab software, and we use Matlab, and we put the equation there, and we got the answer also. So we decide to utilize Matlab's direct integrate approach to tackle the presented issue for the same reason as in question 1 Roman. The procedures to solve it using Matlab's direct integrate are the same as for question 1 Roman. So like we said, it is same. Sym(sx) g equals to inline, g equals to inline function. When we enter, we got this. So we put int gx, and we got the answer here. So the last one pretty and the last answer. By using manual calculation, for formula for integrate by part is integrate u dv equals to uv minus integrate v du with using the acronym LIATE, let e to the power of 2x as u and cos x dx as dv. U equals to e to the power of 2x du over dx equals to 2e to the power of 2x, and we let du to the left side and equals to open bracket to e to the power of 2x close bracket to dx, and then dv equals to cos x dx, integrate dv equals to integrate cos x dx, v equals to sin x. So integrate u du over equals to uv minus integrate u du equals to uv minus integrate v du. So integrate open bracket e to the power of 2x cos x close bracket dx equals to in open bracket e to the power of 2x close bracket open bracket sin x close bracket minus integrate open bracket sin x close bracket open bracket 2e to the power of 2x close bracket dx. And the last answer is e to the power of 2x times sin x minus 2 integrate e to the power of 2x times sin x dx. Due to the fact that the equations they contain the product of two or more functions, we perform integration by parts once again to convert the integration of the product of functions into integrals that could be calculated with ease. So this is u equals to e to the power of 2x, and then we differentiate, we got du over dx equals to 2e to the power of 2x, du equals to open bracket 2e to the power of 2x close bracket dx, dv equals to sin x dx, integrate dv equals to integrate sin x dx, v equals to minus cos x. So we put integrate open bracket e to the power of 2x cos x dx close bracket equals to e to the power of 2x times sin x minus 2 open bracket and open again e to the power of 2x close, and then open minus cos x close minus integrate open bracket minus cos x close bracket open bracket 2e to the power of 2x close bracket dx, and then close bracket. And then we got the last answer is open bracket e to the power of 2x sin x plus 2 e to the power of 2x times cos x minus 4 integrate open bracket e to the power of 2x close bracket open bracket cos x close bracket dx. Because it is precisely the same as the one we started with, we have now arrived at the integral. Therefore, integrate e to the power of 2x times cos x times integrate e to the power of 2x cos x dx plus 4 integrate e to the power of 2x cos x dx equals to e to the power of 2x times sin x plus 2e to the power of 2x times cos x. So the last answer we got is open bracket e to the power of 2x close bracket plus open bracket 2 cos x plus sin x close bracket over 5 plus c. The solution is accurate since the result of the manual calculation and the result of the Matlab calculation are identical. Number 2, the question number 2, if the current in 10 microfarad capacitor is IT equals to 5 TE power of minus 3t milliampere. So one Roman is plot a graph of the current versus time by using Matlab software to graph of the current versus time. So we show you this is our graph using Matlab current versus time, and current from here is 0 and then here. This is y axis and this is x axis. So x axis is time and y axis is current milliampere. Time equals to second. So how we calculate and we got the graph like this. So we use this from use in the Matlab. Person define the time and current vectors. So t equals to 0, 0, 0.1, 10. So I equals to sine t. So this person plot the graph. So plot ti, x level, time s, y level, current a, title current versus time plot. So when we use this, so it will the output will show like this. So time s here, current ma here, current versus time here. So 2 Roman, question 2, find the voltage across as a function of time, plot a graph of the voltage versus time and calculate the voltage value after t equals to 30 millisecond. Capacitor will store the electric charge. The amount of charge stored represented by Q is directly proportional to the applied voltage V. From this, we know that Q equals to CV and take the derivative on both sides of this equation with respect to time t. Q over dt equals to C dV over dt. Therefore, I equals to C times dV over dt. By integrate both sides of the equation, I equals to C dV over dt, we can get the equation for voltage V. So this is how we get the answer of voltage V. So integrate I dt equals to integrate C dV over dt. So integrate I dt equals to C integrate dV, V equals to 1 over C integrate I dt. By using Matlab software, we use like this, okay? So SYMST F equals to inline 5 times T times EXP open bracket minus 3 times T close bracket and T. So it will show you output in line function. So we put again V equals to open bracket 1 over open bracket 10 times 10 to the power of 6 minus 6 close bracket times and T open bracket F open bracket T close bracket times open bracket 10 of the power of minus 3 close bracket. So the output will show like this and then the pretty V. So the answer is here. By using manual calculation, so this is we show you our manual calculation. So we use V equals to 1 over C integrate I dt. So we just replace this C we replace to 10 micro and then I will replace to 5t e to the power of minus 3t m. So we calculate here, we calculate and then we got the answer is V equals to open bracket minus 500 e to the power of minus 3 t close bracket open bracket 3t plus 1 close bracket over 9. So this is U and du, this is dv and v. So this is how we differentiate this. This we differentiate and we got this, and this is we integrate and we got the answer here. So this is the graph of the voltage versus time. So the graph is depends on voltage V, which is y-axis, not to the 0, but in this area. From the graph voltage versus time, V equals to 22635.621 V 1 V after T equals to 30 millisecond. So this is the answer we got from the graph. So here is the graph. By using Matlab software, V equals to 22635.6210 26 V equals to 22635.6201 V after 3 equals to 30 millisecond. The last one, 3 Roman, find the energy ET, plot a graph of the energy versus time and determine the energy stored at time t equals to 0.3 second. Power P is the rate of expanding and absorbing energy. This means that P is the rate of energy change P equals to dE over dt. By integrate both sides of the equation P equals to dE over dt, we can get the equation for the energy E. Integrate dE over dt equals to integrate P dt. E equals to integrate P dt. Energy, which is the work required in joules to move one column of charge from A to B, and this can define as voltage V. Then the current I is the rate of the charge flow. Therefore, P equals to IV. By using Matlab here, so SYMST until the pretty E. So this is how we get the answer. We continue from this to this. By manual calculation, we use P equals to IV. So we got the answer is E equals to 5E equals to 5E to the power of minus 63 times open bracket 3T plus 1 close bracket to the power of 2 over 3 to 4 plus C. And then we continue. E equals to 5E to the power of minus 63 open bracket 3T plus 1 close bracket to the power of 2 over 3 to 4. And then we got the answer is 0 and then we replace T into 0.3. So here also, and then we got the answer 0.0092 J. J means joules. So the computer solution for question 2, 3 Roman are accurate in all since our manual calculation yield values that match those obtained from Matlab calculation. So this is the last graph. So here you can see this. So the graph like this. Okay. Self-reflection, we attempt to use Matlab's integration by part approach to address question 1's difficulty. However, when we compared the computed solution to the answer that had been directly integrated in Matlab, we discovered that it was impossible to guarantee the accuracy of the answer generated using the integration by part approach. Therefore, while solving engineering issues in Matlab, we prefer to employ the direct integration approach. That's all from us. Thank you.